Hey everybody, this is Longo, and in this video we are going to cover graphing hyperbolas. So, hyperbolas in a way are similar to an ellipse, but it's like you're stretching a rubber band and the rubber band snaps and it goes and breaks and it's no longer an ellipse and you got two parts and yeah, you'll see what I'm talking about. Alright, so check it out. The standard form of a hyperbola is extremely similar to an ellipse with one minor detail. One of your variables is going to be negative. That's it. So the equations are going to look identical minus one feature. So if you have a hyperbola that's got a negative y, just so you know, that shape is going to look a little something like this. It's going to stretch along the x-axis. Hyperbolas always open in the positive direction. So then the other example would be is if x is negative, this hyperbola is going to look like that. Now, fair warning, I've seen hyperbolas written in two different ways. Some people like to keep the x first, and then it would just be a negative x plus y squared. But I've also seen it written where the positive one always comes first, and then you subtract the negative one, which would switch your x and y. No big deal, it just means you have to pay attention to where your h and k actually are, and where your x and y and your a and b are actually going. The center is still your h and k, a and b are still the distance to your, in this case, vertices. That's going to be your positive variable now. You don't have to worry about which one is bigger. And then we've got some similar but different parts here. So again, if y is positive, it opens up and down. If x is positive, it opens left and right. They all have a center. So now we have our vertices and our transverse axis. So in an ellipse, that was our major axis, but in a hyperbola, because it's not an ellipse anymore, we have a transverse axis, and that's basically like the distance between your two vertices. A conjugate axis would be kind of like your minor axis of an ellipse, and it doesn't really exist in terms of like an actual line. It just helps you draw the box that we need to do. It still has two foci, and they will still be inside. So because we're going to be farther away from the center, the formula is a squared plus b squared, not a squared minus b squared like in an ellipse. And then we have some asymptotes. Now the asymptotes are going to just be y minus y1 is equal to, your plus or minus slope, but it's your slope times x minus x1. We're going to do point slope form, and all of that stuff is just going to help you graph the hyperbola, okay? So it makes a lot more sense once you actually just jump in and get to it. So again, a general form, we already kind of talked about it. It looks just like an ellipse, except for one of your squared variables is going to be negative, and the other is positive. So in this case, we have a positive x squared, a negative y squared. We know this is an ellipse. A hyperbola. Very similar to an ellipse because an ellipse has two squared variables with different numbers in front, but they're both positive. Hyperbola, one of them is negative. So if it looks very similar, check your symbols. Okay. As far as completing the square goes, this is very similar to an ellipse, so we're not going to spend tons of time talking about this. You got to get your x's together again. You've got to get your y's together. Get your constant by itself. Make sure you factor out your GCF of each, so this becomes 18. And then we have our x squared minus 10x. Half of 10 is 5 squared is 25. And then we're going to factor out our negative 50, which means this is going to turn into y squared plus 2y. Half of 2 is 1 squared is 1 equals, and then of course we have our 50. But then we also have our 18 times 25, which is going to add 450. And then a negative 50 times 1 is a negative 50. And that just put this at 450, because those 50s will just cancel. So we have 18 times x minus 5 squared minus 50 times y plus 1 squared equals 450. We have to get it equal to 1, so we're going to divide everything by 450. And we are left with an equation of 18 times x minus 5 squared over, after we do our 18 divided by 450, that's going to just simplify to over 25. Same thing, minus, I'm just going to reduce this for you now. This is going to be y plus 1 squared over 50 over 450 is 9 equals 1, and now we are ready to graph. So, some similarities. We have a center at 5, negative 1. It's just our h and k. Now, our a and b, that you don't really have to pay attention to which one's positive anymore. But you are going to have to pay attention to, bigger. You have to pay attention to which one's positive. So we have a positive x. We know this is going to open left and right. But underneath our x, we have a 25, so our a value is 5. Underneath the y, we have a 9, so our b value is 3. To do our c value, it's still c squared is equal to, again, this time it's a squared plus b squared, so that's 25 plus 9. So c is equal to the square root of 34, which is approximately 5.8. And then we'll get to the foci in a minute. So, we have 25 is our a stretching to the right and left. So we have b squared of 9, so we're going to go up and down 3. But now instead of drawing an ellipse, what you're going to do is you're going to draw a box. And that's just going to help you draw this hyperbola. So you just draw a box around where those 4 purple dots were. And then you're also going to draw asymptotes, which are diagonal lines that go through the corners of the box. That just sets up how we're going to graph our hyperbola. So then to actually graph it, again, it opens in the positive direction. So you basically just start here at your vertex, and then you just kind of follow that asymptote. And it's basically going to be 2 parabolas, in this case opening left and right. And that's how you draw the actual hyperbola. So you use the a, the b, your asymptotes to find how you graph it, and then you just go do it. So remember, your focus is always going to be inside of a shape. So just like an ellipse, there are 2 of them. So the reason why we had to add is because we have to be farther away from the center to get inside. If it was an ellipse, we subtract, so we're inside of the box. But hyperbola is farther. So since we are going to have our graph inside of the x and y, or the x direction, because the x is positive, our y is going to stay the same. So our focus is going to be at 5 plus or minus 5.8, comma, negative 1, which means you're going to have one at negative 0.8, comma, negative 1, and another one at 10.8, comma, negative 1. So when you graph those guys, it's just outside of, where you are. Asymptotes. Center. That's what we're going to use. So we have y minus y1, which takes it to plus 1, equals our slope, but it's plus or minus slope because we have 2 of them. Our slope is up 3 and over 5. So our slope is 3/5. And then going to x minus our x1 coordinate of the center, which is x minus 5. That is just point slope form from Algebra 1. And that's it. We are done graphing the hyperbola. So again, it doesn't necessarily take that long to do if you're not talking about every little step. So again, this video is a little long, and we've only really done one question so far. But just to show you one more example, if you would like, try this on your own, but pause the video, give it a shot, see how long it takes to graph one, and then come back when you're ready. So if you gave this a shot, you should have a center at 2, -1. Boom, right there. So we have our A and B. This time, notice the Y value is positive, so it's going to go up and down. So again, technically your A is your positive value, so that would be your 4, which would make this your 3. But again, it really doesn't matter that much as long as you know where you're going. So we're going to be going 1, 2, 3, 4 up, and 1, 2, 3, 4 down, and 3 to the right, 3 to the left. This is going to create our box that we are going to use to graph, and that is also going to create our asymptotes. Our C value, C squared, is equal to 4 squared plus 3 squared. That would be 16 plus 9 is 25 squared. 25 is 5. So our foci are going to be 2, -1 plus or minus 5. Again, because we are going to be opening up and down, because our hyperbola looks like this. So our foci are going to be up and down from the center. So that means we've got one at 2, 4, and another one at 2, -6. So at 2, 4 we have a focus, and 2, -6 we have a focus. Last step, our asymptotes. We're going to use our center. So we're going to have y plus 1 is equal to our slope, and then x minus 2. And our slope is plus or minus. We went up 1, 2, 3, 4, 5, and to the right 3. And, or I'm sorry, up 1, 2, 3, 4, and right 3. My bad. 4/3. And that's that. Really not that bad. That didn't take too long. All right, people. Yeah, it's graphing hyperbolas. Obviously, the next video is probably going to be writing equations from a hyperbola. Again, not too bad. This is Longo, and I'm out. See you, bye.